Hi, Miss Spark.
Hey!
This is cool.
How are you?
I'm good.
Good. So, yeah, sorry. I just actually was just waiting for you to come on. I was just packing my lunch for tomorrow, so it wasn't a big deal. Okay. Not a big deal at all.
Awesome. Well, I circled some problems.
Okay, sweetheart.
Packet. Did you send the answers yet?
I didn't. It's a good thing that we're on because you just reminded me that I needed to post that. I'm so sorry, love.
Oh, it's all right. Wait. Okay, it's just live on this. So can anyone in the school join this live?
Well, anyone that I share the link with.
Okay.
The only person I was actually thinking about, but it doesn't matter, was Madison, but I can just text her and ask her. I mean, email her and ask her if she has any questions, but I probably should post this first.
Okay.
Don't you think?
Probably. I was wondering, so is the homework due tomorrow or is that test day?
That's test day.
Okay.
But I was freaking out because I thought I don't want to put too much information without at least getting a quiz, in there to find out the temperature of like how people are doing. You know what I'm saying?
Mm-hmm.
Because what I may do is just make it where it's not, like just maybe do a couple more sections and then do a test instead of, making, because I feel like this first unit has a lot of sections to it.
It does.
So, because the assumption is this is all review, and kind of it is. Well, and technically it's not like any of this that you haven't seen before. Mm-hmm. It's just very intense information to be included all at once and thrown at you. Does that make sense? Like, I feel like this is the most intense unit. I feel like the rest of them don't have quite as much stuff in them.
Interesting. Well, I guess if that's the case, then that's good. Because, I mean, for me, it's just I'm having a hard time because there's just so much going on. But like I don't think it's the hardest thing I've ever done in math by any means.
Yeah, I feel in my personal opinion, but I think you were good at these. For me, the hardest thing to me in algebra 3 is conic sections.
Oh, with the circle, unit circle thing that they all complain
Well,
about?
no, that's trig. That's like hyperbolas. Did you do those in algebra 2 last year?
I know parabola, but not I don't think hyperbola. Maybe what does it look like?
Um, let's see. Let me draw one. When you draw them on the graph, they actually look like that.
Oh yeah, we did do those. Yeah.
Yeah. Yeah, I those to me are the hardest things because I introduce a lot of like, well, it may not be new to you, but it's definitely new to some of the students in here.
But my dyscalculia,
Although,
again, I don't remember anything, so it will look new to me. But I now since you drew it, I do remember seeing that.
yeah, I feel like because it's ellipses, circles, hyperbolas, and I feel like there was maybe it's parabolas. Maybe we do parabolas just so that that's a familiar shape. It's like, oh, well, let's just throw in at least one familiar shape.
Yeah, it's. I remember in the calculator, it was a little weird in my calculator when we were putting that in.
Yeah. Yeah.
But I usually like calculator math out of all of them.
Yes.
So, do you want to start, or do you need to post the little answers
Well,
first?
I'm posting the answers
Gotcha.
because I feel bad that I didn't do that. So I'm sorry.
No, it's good. It's been a crazy day.
It has been a crazy day.
Woo! Good old
I,
Thursday.
no doubt. And thank goodness it is Thursday for real. It's been a crazy week.
Yeah. I don't know if Mackenzie feels this, but I feel like this is the week where we all have all the tests and the quizzes.
Yeah. And I felt kind of bad doing that because I saw that y'all had 2 others for tomorrow. It looked like. And let me look at something real quick. Yeah. Okay. Which ones did you circle, baby girl?
Okay, so I would love to go over number 7 again because I just need to walk through it again. It's just a little complicated. It's a little multifaceted for me.
Okay. Sounds great. We'll start there. And it leaves me lots of room here too. So I'm gonna do this.
That'd be nice. 2x.
And because I know that you like steps.
Yeah.
Come on. Where did you go?
Hey, do you have any more of those? You know how you used to give me last year that like that website that had like the steps with it and how to solve everything? Do you still like have those?
Sometimes I do. I'm trying to think if I have one for the exponents. That's what I'm thinking. Let me see what I can find on exponents.
Okay.
Let me just see what I can find there. And I'm processing. I'm sorry, because I'm trying to think what do I have for that. All right, like I say on these, I would start inside for the groupings.
Okay.
Okay. So I would just write groupings if I was taking notes. If I were you, will that mean something to you? Groupings, like, well, that's like the numerator and the denominator. Handle each one of those first. Like handle, what's on top first.
Okay.
Okay. So what I'm going to do then is distribute that -3 to everything on the inside.
Okay.
And I would just write it exactly like this.
Okay.
X to the -3. And then 4 times -3. I'm sorry. My greyhound likes to talk to me when I'm on like Math Lab or Google Hangout, so I have to let her outside. I'm sorry.
It's okay.
You're not going to teach anyone math, honey. You're sweet and cute, and I like that you want to join in the conversation with us. I gotta work.
This is so helpful. I like that I can actually see what you're doing.
Oh, you like that?
Yeah.
Good. I'm glad. That's why last year I wanted to try and get your worksheet so I could do this.
Yeah, I'd also just send them to you.
So okay, so now we've done that part, and now we're going to do the denominator. And what we're going to do for the denominator is, since there's a multiplication going on, we're actually going to, like, it's 2 and there's no coefficient on the second term. Does that make sense to you? Like, there's a 2 here, but there's no coefficient on this one. Does that make sense? Or no?
Well, okay, so I see that you x's, yeah, there's no coefficient on the x to the -4th. Is that what you're trying to say?
Correct. That's what I'm trying to say. So basically all I'm going to do is just bring the 2, because that's technically like saying 2 times 1. Okay. And now we have an x to the third and an x to the -4. And when things are multiplied, you add them. So that's going to be x to the -1. And then we have y to the -3 and y squared.
And then y, okay, so -3 plus 2
is going to be -1.
Okay. And now you're going to bring back the parentheses and then
yes, ma'am.
-3. And then now you're going to distribute it to them all again, right?
Okay, what I would do personally first, this is just me. You could distribute it to everything. But what I would do personally first is I would actually combine the exponents inside and then do that on the outside. But if you want to do it the other way, we can. I don't care.
I feel like that's going to be a little complicated. So let's just combine the ones inside first.
Okay. All right. So what I have the same bases on the 2, and this is an understood 1 down here. Okay. Does that make sense? Huh?
Where are you talking about the understood 1?
On the 2 that I just drew it.
Okay.
Right here. I drew that, but that's an understood 1.
Okay.
Right there. So that's -3 minus 1.
Okay.
Okay. So that's going to be, so that would actually look like this. Okay.
Okay.
All right. So then I'm going to end with 2 to the -4.
Okay.
Or 2 to the 4th.
Now you're going to take the -3.
I'm so sorry about it. Can you hear my greyhound whining?
Yeah, it's okay. I promise.
So
now you're going to take the -3 minus it by -1, which then you add it really. So -3 plus 1 is -2. So x to the -2. And then you're going to take -12 minus 1, which is -13. Now,
actually, that's going to be a -12 minus a -1.
Oh, so +13.
Yes. No, +11. I mean, -11. So -12 minus a -1 is going to be a -11. Does that make sense?
Yes, ma'am.
Okay.
I just type it in right. Okay, and then you're going to take everything to the -3.
Then I'm going to raise that to the -3. Okay. So 2 to the -4 times -3.
Wait, okay, so I'm going to raise 2 and then wait, up to the -4 times 3?
Yes. Times -3.
Okay.
Because see, it's a negative.
Oh,
okay, so that's going to give me 2 to the 12th. And then x to the -2 times -3.
Wait a second. Sorry, I'm getting a little confused. Okay, so I typed it in weird. 2 to the negative.
If I were you, instead of writing it down at this point, like typing it in my calculator, I would just do -4 times -3. Does that make sense?
Nope. Oh, okay. Wait, yes. Sorry, -4 times -3.
Yeah, I would go ahead and write my bases and just take my exponents and deal with those. If you want to type in -4 times -3 in your calculator to make sure you get that right, but I wouldn't bother to put the bases back because basically all you're doing right now is applying the exponent rules.
Okay.
Okay.
So 12. So 2 to the 12th is really what you're doing.
Yes, ma'am.
Okay.
And then I've got x to the -2 raised to the -3 power. So that's going to be a +6. And then I would write down my y because that's my next base. And I would do -11 times -3.
Okay.
And
So
that's going to give me a +33. And quite frankly, to be perfectly honest with you, if you wrote 2 to the 12th power, x to the 6, y to the 33, and you didn't bother to write 4,096, I wouldn't be sad. But if you wanted to go back and type in 2 to the -12 in your 2 to the 12th in your calculator at this point, that'd be fine too. I don't care.
Okay, I'm just gonna take the extra step because I feel like I have a lot of calculator malfunctions a lot.
Okay.
Okay, that was simpler than I wrote it yesterday.
Yeah.
Okay.
Well, I think the hard part about doing it in class, it's a wonderful thing, but it's a bad thing at the same time because everybody has different questions. But it's great that everybody has the questions because, oh, I wouldn't have thought to ask that question. You know what I mean? So it's good, but sometimes it can take a little longer to process through the problem, so it seems longer. Does that make sense? And when I can, I'm sorry?
I'm a little dead, like hearing something. Period. I'm just like done mentally.
Oh yeah, I hear that too. All right. So you feel pretty good about that?
I think
Do you want to try? I'm sorry.
Say that. I think I just need to take it step by step.
Yes, and that's what I would do, and that's what I said. There will only be one like that, and I think it's number 7 on the quiz as well. But the rest of them, just take it little by little by little. Like on number 8, it's not raised to a second power, so you're just going to take each individual grouping. You know what I mean? Do you want to do number 8?
Yeah, let's do that again.
Okay, so I'm going to start with my grouping. So I'm going to work on my numerator first. And then the numerator, I'm going to distribute that -1 to both the m and the n. So on the numerator, I'm going to have m to the -1. And then I've got 4 times -1. So that's m to the -4. And now on the bottom, I have 2 times 2, which is going to give me 4. And then I've got an n to the second in the first term. And then I've got an n to the first in the second term. So I'll add 2 plus 1. That's going to give me n to the third. And then I've got m to the -1.
Okay.
So now I don't have a constant up here, so that's a 1. So that's just my 4 is going to stay down here.
Right.
Then I've got -1 minus. Oops, it's weird because it's reversed.
1.
Yeah, I've got -1 minus a -1. So that's -1 plus 1. So that equals 0. And anything raised to the 0 power is 1. Okay, so I've got a 1. And then I've got -4 minus 3 for the n. So -4 minus 3 equals -7. So I have n to the 7th.
I'm a little confused why you put the 1 up there, just because I thought it would go on the bottom. Because the m's do cross out, but I thought if you could do something to them, they would go on the bottom as well, like the n did.
Yeah. But since it ends up being 1, 1 over 1 is the same as 1. And since I didn't have anything up there, it gives me a 1. Does that make sense?
Mm-hmm.
So that's why I stuck it up there. Does that help? Should seeing it as 1 over 1?
Mm-hmm. I just wouldn't have seen that. Okay.
Okay.
Okay, so let's move on to wait, where's my sheet? Can we work on like 16?
Absolutely.
Those look a little squirrely.
Okay, we're going to rationalize that.
Okay,
Sorry.
can I tell you how I think I would do it, and then you correct me?
Yes. Let me see if my dog is just barking at something random or if my hubby's home. What are you barking at, buddy? Hmm? You need to go out on the back porch with your sister? Okay, sorry.
You're good.
Okay, tell me what you would do.
I would multiply it both sides by the square root of 5. And then I would do equals, and then I would do like -3 and then square root of 5 and then over 5.
It's perfect.
Oh, really? Oh, good.
Yeah.
Well, there we go.
Yay!
Okay, now 18. That was my next question.
Okay.
This one's
okay too. And I really wish we would have gotten to these in class.
Uh-huh.
And I think if there is one like this tomorrow, and I'm going to have to look at it, because I didn't have a chance to really go over it in class, I'll probably just work it out and it'll be a gift, because I do not like to test on material that I haven't covered. I just don't like to do that. But and this is similar, but there's a little caveat to this one. When you have, and this is like this goes all the way back to like pre-algebra.
Oh.
Yeah. When there's a square root, you want to see if there's any perfect squares within the square root, and you want to make sure you take those out before you rationalize the denominator.
Oh, so 4 would be it.
So on number 17,
I'm looking at 18.
We're looking at the square root on the bottom, because you don't want the square root on the bottom. You don't want the radicand on the bottom. So what we're looking for is perfect squares within 18. And 9 times 2, right?
And then 3 and 3.
So 3 is a perfect square. So if I had this like that, I could pull the 3 out and only the 2 would be left in. Do you agree?
Yes, ma'am.
Okay, does that make sense to you?
Because the 3 came out and then the 2's left over.
Okay, so I'm going to erase that since we saw where it came from. Okay, and what that would mean then is I have this right here. I have 3 times the square root of 18 times 3 times the square root. Oh, my bad. Yikes. Now I have 3 times 3 times the square root of 2. Because this simplifies to this. But I still have this on the outside. So I have to multiply that. Does that make sense?
No.
Okay.
I'm not seeing where you get the extra 3.
I have the 3 because it's right here. Okay. And then the 18 is 9 times 2. Okay. So when I take the square root of 9.
Yes, I'm sorry. I see it now. Yes.
That's 3.
Yes.
Okay. So 3 times 3 is 9 times the square root of 2. Does that make sense?
Yes,
That's
ma'am.
where I got that. That's that. Does that make sense where I got it?
It does.
Okay, good. All right. That's why I said I would probably do this one for you guys. You know what I'm saying? Because it's just a little bit of an extra step. So now on the bottom, I'm technically got 4 times the square root of 21 over 9 times the square root of 2. That's where I am now. Okay? Because if that is this simplified.
7 times 3, which nothing can come out there.
No, not anything would come out there. So in order to rationalize this denominator, all I have to do is multiply the top and the bottom by the square root of 2. I don't have to worry about that 9 at all. Okay?
Mm-hmm.
So now I have 4 times the square root of 42 over, and then this would be 9 times 2, which is going to be 18. Do you see where I get that?
Mm-hmm.
Okay. But now that will actually reduce, and it will be
yep, because you can knock out the 4 and the 18.
Over 9 and with the square root of 42. Let me see if I'm right. I did all that. Let's pray Miss Sparks knows what she's doing. Okay, and I am. There it is right there.
Good. I honestly think the radicals that we're doing, the big long one, is harder than that one.
You think that like the exponents
I
are
think
harder
for me, yeah.
Oh, okay. Or the ones where you have to do the conjugate. Oh, goodness.
It's a little harder, which I need to do next.
Okay, so you didn't think that was too bad?
Mm-mm.
Oh, yay. Good.
I mean, I work better one-on-one. I feel like in class I never get anything, but like okay, that kind of makes sense-ish.
Oh, good. Good. Well, maybe I should just work on the board in front of you. Maybe, no, I mean, maybe that would help. I did have some students that worked better for, and then there are other students that just they don't care. You know what I mean?
I honestly, like yesterday, whenever you brought me up to the board and I was doing that kinesthetically because I could make my mistakes on the board, that helped me a lot.
Oh, well, praise the Lord. Well, I'll do way more of that.
I would totally be your marker at any time.
Oh, good. Good. That's awesome because in all honesty, students love to watch other students do it way better than watching a teacher.
Okay.
You know what I'm saying? And it was funny. That's so funny that you say that. I don't even know if you'll remember Claire Dean or not, but because I think that was the first year that's how she learned. And she literally wrote for me all year long.
Okay.
Once we figured out that's how she learned best. And she went from being a B student to an A student.
Wow.
I know. It was really amazing. And it was great for me because she had way better handwriting.
Can't promise that for me, but
oh, that's all right. If it helps you learn and it's more fun. I think Nathan learns better that way too.
Yeah.
So, and I'm okay with people doing partners too. That's always fun. And then I have another game that I play every now and then, where one person is the writer and the other person is the speaker, and the writer can't talk at all. All they can do is write, and the speaker can't write at all or do anything. Like they can't point at the paper or anything. They just have to be able to articulate what you're supposed to write.
That's a little daunting.
Yeah, I know. It's a little scary because you know, sometimes the syntax in math is what gets people confused. You know what I mean?
Mm-hmm. It looks scarier than it needs to be.
Yeah, no doubt. Let's see.
So do you want to do 19 or 20? Is that the
okay, we'll do 19 and 20. But I want to point out on number 18.
Uh-huh.
This particular piece at the top, that is a perfect square. So really the one at the top would actually be 16 over 3 times the square root of 14.
Oh, I get it. I see it now, Miss Sparks. You take 44 and then that times it by 4 because it comes out of the radicand, and now you get 16. Okay.
And so then you would just have 3 times 14 on the bottom, which is what, 52? Is that right? 42?
I think so. I'll have to type it
42.
in.
So it'd be 16 times the square root of 14 all over 42, which then reduces to 8 times the square root of 14 over 21. Yes. Is that right?
Mm-hmm. Yep.
Yeah, there's the answer. Yay. Okay, so I'm going to erase all of this so I have plenty of room to write. And the only downside about some of this is me trying to squeeze my work in. So what I might do, Ellie, if it's okay with you, is actually rewrite the problem over here to the right.
Yeah, I don't mind.
Okay. What I'm going to do is just do the conjugate part down here and then move it up over here.
Okay.
Okay, so the conjugate for this one.
Okay, it's gonna be. Wait, sorry, I need to look at it. It's a little too small on your screen. Okay, be like 8 minus 7 square root of 5, right?
Good job. That's perfect. Okay, so what we know, because this is the difference of two, oops, sorry about that. Because it's the difference of two squares. I mean, that's the whole point that we're doing the conjugate, so that that middle term cancels out. Does that make sense?
We're going to FOIL it.
Like if you FOIL it, that middle term will cancel out because you'll have a plus 7 times the square root of 5. Or actually, you'll have bigger than that. It'll be 56 times the square root of 5 plus 56 times the square root. And then you'll have a minus 56 times the square root of 5. So that middle term will cancel out. So you can really just kind of shortcut yourself and multiply the 8 and the 8, which would give you 64. And the 7 times the square root of 5 and the 7 times the square root of 5. Which would be 7 times 7, which is 49, times 5. Does that make sense to you?
I'm just going to FOIL it just so I don't get too confused. Just gonna do FOIL.
Okay, that's fine. We can do that for sure.
Okay, this is kind of weird because it has a square root thingy. Okay, first, outer, and
last.
So I'm kind of stuck on like the inner part. So 7 times, I guess 8.
It's going to be 8 times the times negative 7 square root of 5, which is going to give you negative 56 square root of 5.
Okay. And then last, which is...
And then the inner is plus 56 times the square root of 5. And last is negative 245 because you've got 7 times 7 and the square root of 5 times the square root of 5, which is 5. So you're going to take 49 times 5. Which is what I did up here.
Why is there a 36 right here?
Where?
Next to the 56. Oh, it is 50. Oh, sorry. It looks like a 3. It's a 5.
Oh, I'm so sorry. It's my writing.
It's okay. It's good. It was a 56.
It's not like I have great handwriting to begin with, and then trying to write on this screen is a little spooky. So but that's what I'm trying to say. The whole reason right here, the whole reason that you multiply by the conjugate is so that this middle part will cancel out.
Mm-hmm.
So you really don't even have to think about, you know how the word FOIL, you have the word FOIL like that?
Uh-huh.
You don't even have to think about the O or the I when you're doing the conjugate.
Okay.
Okay? You just have to focus on the first and the last. That's the whole reason you're doing the conjugate. It's based on the principle of the difference of two squares. Do you remember the principle of the difference of two squares? No, maybe. Yes, no.
Mm-hmm.
X plus 3
and x minus 3.
Minus 3. The whole point is that those two cancel out. So you're left with x squared minus 9. That's the same principle going on here. Because if you were to FOIL that, you'd have a plus 3x and a minus 3x, which then cancel out. So you're just left with the first and the last. And that is why we multiply by the conjugate to get rid of the radicand in a problem like this.
Right.
Okay. So now we have 64.
Negative 181.
Okay, so it's negative 181. And then you would distribute this 4 to both of those terms, which 4 times 8 is 32. And 4 times a negative 7 times the square root of 5. So your final answer should look like that. See if we got it right. They wrote it differently than we did.
So the 4 doesn't go to the square root of 5, right? Just whole numbers.
Hang on just one second. Sorry. Oh, that's what they did. I don't know why they did that. Yeah, just the whole numbers.
Okay.
They wrote it really weird. Look how they wrote their answer. To make that a plus, they did that as a negative, and I don't really know why. If I multiplied this by a -1, I'd get that, but I like my answer better. I wouldn't want to start with a negative. You know what I mean?
Mm-hmm.
It's the same thing, but okay. So how was that? Horrible?
Not too bad. And then again, this one you're just going to distribute the top. Because I feel like the one we did yesterday, I did on the board, I had to FOIL the top as well.
Yes, you did. You did have to. You're right. And I don't know if I have one like that on. That was for the homework, right?
Mm-hmm.
I don't know if I have one like that on the quiz. I'll double check while we're on the phone. I mean, while we're on Google. Sounds like the phone, doesn't it?
Yeah. I'm just foiling along.
Have you already started on 20?
Mm-hmm.
Oh, wow. So are you doing the whole FOIL thing? Or are you just doing the first and the last?
I'm trying the first and the last method.
Yay! Good for you. You're all brave now, Ellie.
And then okay.
So what did you get this?
And then 14 minus. No. Yikes.
What'd you get?
I got 14 square root of -2 over 49, 7 square root of 2.
Okay. Let's see what. Okay, let's walk it out and see what we did. Okay. What was your conjugate?
Okay, 7 minus square root of 2.
Okay, so 7 minus square root of 2. Okay, so when you FOILed it, what's the first?
49.
Okay, so 49. And what would the last?
I thought it would be 7 times square root of 2, so I just did 7 square root of 2, which I think that's where I messed up.
Yeah, let's talk about it so you can see it. Oops.
Maybe I do need to FOIL all the way out.
Well, let's see so that you don't cause yourself more work. Tell me what two numbers are the last.
Oh, it's square root of 2 and square root of 2.
Correct. So what's the square root? What's the positive square root of 2 times the negative square root of 2? Because here's the first, and here's the last. So what's positive square root of 2 and negative square root of 2? Because remember, the whole reason you're doing is to get rid of them. What is that?
0.
No, like times.
I'm sorry, I'm having a hard time with this. I don't know.
You just pull it out.
Okay, so just 4 or 2?
2. Well, because technically you're right. It would be the square root of 4, which is what?
2 times 2, and then you just pull the 2. Oh.
Right. So, because if you multiplied them and left them in the radicand, you would get you would get square root of 4, right?
Right.
And what is the square root of 4?
2.
So that's where that comes from.
Mm-hmm.
Okay. So when you look at it, remember, because the reason why you're doing the conjugate, first of all, you want to get rid of the radical. So if you end up with a radical in your answer, you know you FOILed something incorrectly. And when you're FOILing, when you're doing the conjugate, it's the first, which are the first two numbers, and then the last two numbers.
Mm-hmm.
And that's to get rid of that. So 49 minus 2 is what?
47.
Okay, so you got 47 on the bottom. Now distribute that 2 to each one of the
So we
terms.
got 14 square root of, 14 minus square root of 2.
2 times the square root of 2. Because you're distributing it to that, right?
Oh, okay.
Does that make sense?
Mm-hmm.
Okay. With dyscalculia, this like you're just gonna have to take it one little step at a time.
Wait.
What?
Can't you just put it over 47?
Yes, I just haven't done that step.
Okay.
Sorry. So that should have been your final answer.
Okay.
And you know, I don't know if this will be better or worse for you.
Mm-hmm.
But when you're thinking about that square root of 2, or eventually when we get into imaginary numbers and it's an I, because complex numbers are, either an I or a radical. That's considered a complex number.
Mm-hmm.
It's almost like dealing with a variable, Does that make sense? So like if I had, when you're multiplying I don't know if you struggle with this, so I don't want to introduce a struggle. But when I said to distribute this 2 to the square root of 2, I just want to make sure you know that you leave it like that. Does that ever confuse you, or are you straight on that?
So you're saying like treat it like an x, like 2x?
Yes, ma'am.
Okay.
Like don't be tempted to put the 2 inside the radical, I guess is what I'm trying to say. Just like that square root of 2 would be the same thing as an x, and you can't really put the 2 inside the x. You just put it next to it.
Mm-hmm.
Okay? Does that make sense?
Yes, ma'am.
Okay, good. Do you want me to make up a few more? Or do you feel good? Are you like worn out and done with math and school?
I think those are okay. Can we do like 15 or 16 because those we haven't done it all today. No, we did 16. Yeah, we did 16.
Yeah, I can do whatever one you want me to.
There's one that, like, you know, like you flip the fraction. Those are the ones that really get me on edge. Where you, like, you know, do the 1 over something. I don't know. I'm having a hard time with, like, the process with the whole, like, raising the power to something and then over 1. I don't know.
Oh, okay.
Like the ones we did in our homework. I don't know if there's any on here that are exactly like that.
Okay. Like, are you thinking like number 14? Or are you good with that one?
Let me see.
Is that what you mean? Like when you have
like those
16x to the 8th, and then you take the denominator, it goes in the little root thingy.
Yes, ma'am.
And then the answer, whatever the answer is then raised to the 5th.
Mm-hmm.
Those?
Yes, ma'am.
Okay. So the 4th root of 16. Do you know how to do that on your calculator? I think you have to hit the 4 and then math and then arrow down and put the 16 in. Like arrow down to the root thing, which is number, I think it's 5 in your calculator.
Uh-huh.
And then put 16 and then hit enter.
I kind of lost my calculator. I can't find it today. So I have just the
Well, I can honestly tell you this is 2, and if y'all need me to tomorrow, I'll be your calculator.
Okay.
I know it's geeky of me, but I know that the 4th root of 16 is 2.
Okay.
2 times 2 times 2 times 2 is 16.
So in steps, you take the
4th root of the constant. Oh, I'm sorry. You tell me what you do. I apologize.
No, it's okay. So take the 4th root of the constant, and then once you get that number, you bring it down, and then do you take the root of? Oh wait, no, you multiply 4 times 8, right?
Well, you don't multiply. This time you divide, and let's think about why.
Because you're doing the opposite.
Yes, we are. Because like if I said to you, Ellie, what is x to the 4th raised that's squared? What would you tell me?
X to the 8th.
Right. So, or the other thing, actually, what I would do, that's wrong. I did it wrong. I would do this. I would say, Ellie, what is x squared raised to the 4th? You would tell me x to the 8th. Mm-hmm. So see this right here? That's the 4th root. Mm-hmm. So 4 goes into 8 2 times. Yes?
Yes, ma'am.
So that's what you've got. And now the numerator says I'm going to take my answer and raise it to the 5th power. So now I'm going to take 2 and raise it to the 5th power, which is 32.
And then x times 2, 10.
Yeah.
X to the 10th.
Right.
Okay. Yes, ma'am.
All right. So now let's think about 13. Mm-hmm. Because it's got a negative in there too. Mm-hmm. Which tells me it's just going to go in the denominator because the negative says it's going to be a fraction. Okay? That's what that does. So the first thing I can do is put it in a fraction because of the negative. Okay? Does that make sense?
Can we write it first before we do that?
Well, okay.
Or you have to do this first before you write it?
I kind of have to do this first because of the negative.
Okay. So 1 over, and then like.
And now I'm going to take n to the 4th. And this tells me it's a square root. Okay. And then my answer will be raised to the 3rd power.
Okay.
But The one over that takes care of the negative.
Okay.
That's what you do. The negative tells me that. So I am kind of handling it right away. That's what I need to do. Does that make sense?
Yes, ma'am.
Okay. So now, with my messy writing, the square root of n to the fourth is what?
It's just it's 12.
The square root of n to the fourth.
Oh. That is into the second.
Yes, good job. N to the second. And then that's raised to the third power. So what's that going to be?
Into the sixth.
Good job.
Over 1. Keeping the 1. Yeah, those were, to me, the hardest ones.
Okay. All right. The exponents, not your favorite.
Not my favorite.
Okay. All right. Well, then you do number 15. Walk me through it.
I would say first you're going to take 4p to the 6 and then put the 2 above the check mark and then put a 1 on the other side. And then you're going to raise 4. Wait.
Am I doing this right? To what you telling me?
And then and then 1 right there. Yep, that's just like my paper. So then I'm going to take 4 to the second, which is 2, right?
Yeah, the square root of 4 is 2.
And then I'm going to divide 2 by 6, which is 3, so p to the 3. And then I'm raising that all by 1, which is the same. So just
there you go.
p to 3.
You did it.
Okay. Oh, okay.
You did it. You did it. You did it.
Good.
You have all of your answers in front of you? You want to check them?
Oh, I still need to do 3 and 4 and 5. And I think I have I should do 3, 4, and 5.
Oh, okay. Do you want to do them now?
Sure. I'll just do them right in front of you because I think these are the easier ones. So you got over the parentheses or the dimensional analysis. No, I can't even talk. The absolute value.
There you go. You sound like me. Bless your heart. That's how I sound. I feel like that's how I sound 7th period after I've taught all day. I'm just like, oh my gosh, I hope y'all love me.
Yes.
Because I'm like, what is this? What do I teach? Who am
I? Take out the absolute value and equal it to -2. Now you're gonna times it by 5. Times it by 5, so p equals -10. And then also we need a positive, so p equals +10?
Yeah, it's going to be plus or minus 10.
Yep, okay. Good. Now I'm going to do this one, 4, which is going to be b equals plus or minus 28.
Yes, ma'am.
Now 5, we're going to do p equals 0 and p equals, let's see what it is. So 0, right?
Yep. P equals 0 or p equals -2.
Okay. Okay. That's not bad.
Those are the easy ones.
Yeah. Just gotta study some more. Okay, I think that's good now.
Don't stress yourself out too much.
Okay, thank you.
Yeah, please don't.
No.
I was going to say, even if I even had students in my Algebra 3 class that I wouldn't do anything, it just helped them to come up to my desk and walk through it. They would talk about what they did and they would talk about it with me.
Mm-hmm.
But I didn't really help them. It just helped them to process it out loud.
Yeah, test anxiety. Like I swear, if my mom was next to me when I took the ACT, I would do so much better.
Yeah.
I know the answer. She just, it just helps to have her there.
Yep. Yeah. So if you need to do that, feel free. Whatever you need to do to get through, I'm there for you.
Well, thank you. And thank you so much for meeting with me last minute.
Oh, no problem. No problem. Thanks for being flexible about my other 2 math labs and my dinner time.
Good. You definitely you have a life.
Oh, well, anyway. Well, you're a sweetheart, honey. Thank you for working so hard. Please, please, please don't stress about this. We will get through it. I promise.
Thank
You
you.
are an excellent student, and you just need to relax in that and know that the Lord has you and I've got your back. Okay.
Okay, thank you so much, Miss Sparks.
I love you. Have a good evening.
Thank you. Bye.
Bye bye.